Hello everyone, it's Peter here, Piotr Fissner. How are you doing, guys? Hello. So this is a part 3 of Electronoobs inverter, 12 volts to 220 SPWM. So it's a sinusoidal, yes, sine pulse width modulation, based on the module, this module, yes, which is a QS1-100 model. So I've shown the beginning of the process of how I was building it, and now it's the final part when it's built. Yes, now there are a few issues with it, okay, and those issues I will tell you about. I've built it first time in my life. I never built it before, so it's the first time I've ordered 5 of those PCBs from JLC PCB Ways or something, I don't remember. JLC PCB, something like that. It doesn't matter. It just was cheaper than PCB Ways, so I've ordered it from over there. Now, I'm a paid subscriber on the Electronoobs YouTube channel, and I wanted to build this inverter to learn more about inverters and to have a knowledge, you know, how to fix them, what are the topologies and so on and so on. So I said, by building one, you know, it will be the best choice. And then I'm going to build another one with, there is a transformer over there, yes, that costed me £72.05, believe me, whereas whole this wasn't costing me that, I'd say, yes, maybe. I don't remember the prices, but if I would calculate item by item, probably I've paid less for the whole inverter here than only for that transformer. Okay, so yes, you might be asking why you want to build that one if you can have this one, and that's a good question, and I don't have an answer to it. I know that Victron Energy, which I've got here, is based on a toroidal transformer, so those are low frequency inverters, yes, whereas this one is a high frequency inverter. I know from my experience in electronics that toroidal transformers are more robust than these, but I wouldn't agree perfectly to that. When it's come to the pure sine 50 Hertz, what we've got in our mains, or 60 in some of the countries, you will need it for certain applications, and for certain you don't. So if you want to plug in your computer, your medical equipment, your hi-fi, it's better to use pure sine, so 50 Hertz. Whereas if you plug in power supplies, chargers, even lightning, yes, most of the time, not all, but most of the time, you can use high frequency. Whereas this one is on a high frequency transformer, but still producing pure sine thanks to this chip. It's called EGS002. This has built-in even soft start, so when we will plug it in, you will see that it's a soft start. I've corrected, there was an issue in the schematics of Electronoobs. I'll show you those differences which I found. Okay, so you can check that electronoobs.com website, and you can check you've got an inverter over there. So let me zoom in here. Okay, so resistor 24 and resistor 23, which are at the pins 5 and pins 6, so CT and RT, that was 10 ohms written here, okay, and that was written 33 ohms, okay, sorry, K, so 33 kilo ohms. So the problem is that when I checked the schematics, I wanted to follow the schematics, and I've placed those resistors here, and that was a mistake. And when I turn it on, it gives me wrong frequency. You could hear wrong frequency, yes. So now I had to remove them and look at the original board, what it has, because that has as well 12 volts to 220, yes, this transformer. So I've checked, and it wasn't 10 ohms but 100 ohms. It is on this board originally, and the 33 kilo ohms on the pin 6 is actually 3.3 kilo ohms. So that's why I had an issue with the frequency. I still have either wrong setup of the PWM signal, so I still need to check that whole setup of those resistors and capacitors. But as I didn't test it before removing all those components from one of those boards and placing them here, so I don't know in 100% if this was working originally, yes? So I need to take more time. That's why I wanted to record this video, so that you've got an update and you will know. Use all the components from this board, you know, for this section here, and then you'll be fine. Another thing is that Electronoobs have this input capacitor as a 1000 microfarads as well on the schematics, but on the video he's showing 4700 microfarads, and guess what is here? 4700. So follow this, don't look at the schematic. On the input side, try to base design. If you know how to do it, you won't get killed, you know, and you can follow procedures, because that can kill you guys, yeah? So if you're going to plan to do it and you've got knowledge and you're willing to experiment with it, keep in mind to keep those components one-to-one here, okay? Don't look at the schematics as I did, because I like to double check myself. So when I've soldered everything and I've seen that they are wrong from this, because the schematics stating otherwise, I wanted to update it. So I took my bunch of my resistors and I placed those ones, yes? But then I start to hear this weird hissing sound, so the wrong frequency was there. And then I recorded a video part, I think 2, so I said about the CT and RT, and these are to adjust the frequency of the PWM signal and the dead zone, or that time in between switching of the MOSFETs, yes, because if they will switch in the wrong at the wrong time, they can cause the damage. So you need to be 100% sure. Now another tip when you want to build it is to align those, even if you can screw them together, you know, and then start to solder them, so you will have a one height. Then again those. Now this design have an issue, because those MOSFETs usually they are mounted on the outside and IGBTs are mounted outside. That's the commercial inverter, okay? And Electronoobs was based, Electronoobs design was based as well on that. You see you've got top and bottom. Now he based his design on the commercial, so I assume that he's seen that it was outside and outside, yes? So he should follow that procedure, I mean the design, yes? He should take those on the outside to use enclosure as a heatsink. Why he haven't done it, I don't know, you might ask him. But if I would see the design in the commercial like that, I would question myself, should I place it in the same way or maybe no? And probably I would, yes? Like for instance, you could use this board instead of part of this board here, and just literally use these to connect. If you've got thinner wires, you can connect 2 or 3 wires to one pin, another to 18 volt, but to the 220 volt and the 0. Or actually we use here I think 380. So 380 few wires if they are thinner or thick one, depend how many amps you want to pull out of it, and then 0 here. So you could literally do it this way, and when I'm doing it, then this is working fine. When I'm using this setup here, this one, rather than plugging in this one and sourcing from this, then what's happening now, the sound is right. That's see 12 volts, 0 amps. Okay. Ooh, it's frozen. No. What happened to my camera? I'll pause and I'll fix it. Sorry, I can't show you. I thought I can, but it's taking more current still. That's why I know it's bad. I didn't even use my oscilloscope. Okay, it's over there. I thought it's over there. My oscilloscope to check the frequency, but I know as a fact that it's bad. The rest of the inverter looks fine because now I've got not up to 202 volts, but I'm reaching 220 volts, so it's fine, you know. What do we have? DC, so we need AC, true RMS. Okay, good. And you'll see that it will be soft start when I will plug it in. So it's taking 4 to 5 amps. That's why I know it's bad. Yes, and the heatsink sound, you see, it's quiet. 40, 114, 116, 220. Yes, so you see it has a soft start and it's working fine. But those MOSFETs here are okay when they are not used. When you start to use it, let's turn on the light which is soldered to this. Yes, observe this and observe that light will light up, but I'll tell you that it will be really hot and you'll hear weird noise. So that means either some of the components I soldered still are not correct here, so again I did base it on the schematics, or some of the components are faulty. Yes, I don't know that yet, only I wanted to show you. That's why base on this rather than base on the schematics, because schematic is bad. Yes, so again the same test. Yes, and hear the sound. Yes, hear the sound and you'll see that the light will now be turned on. It's okay, and you hear, see, it's reaching this 220, but it's given this noise and they start to become warm. Not IGBTs are still okay, and it's too short period. It doesn't pull too many watts, that's why, you know. See, soft start, we've got now reached 220. Yes. Okay, let's disconnect. Still okay, but if you use it longer, yes, if you use it longer, then it's becoming hot, and that's why I know there is still an issue. So I need two things now. I need to find a way to make this part working again the right way, and I know it only should consume 20 watts. So this bulb is let's say 5 watts, yes, then that's in total should take about 20-25 watts, not more than that, which is bad, but you know, just what it should. And then you've got about when it's working, yes, when it's working, you should have about 80% efficiency, so input minus output, yes, then you will have the difference, and it should have over 80% efficiency. We will test that. I won't make videos probably about it for now. I wanted to just show you that it is working, it is fine, and I need to do those two things. So now fix this part still fully, because I still don't like it that it's getting too hot. Then put the radiator on it is a second part with an enclosure and the fan. Yes, so that's what I'm going to do, but it is working. And again, don't follow the schematics as well. Another thing what I wanted to show you is I didn't have components as Electronoobs had, so I've used, do not touch anything because that will be funny to look at me when I will be there. So this capacitor and this capacitor are different, okay, they are different, and I've used those because I bought on eBay. I've shown on the other video as well, part 2, but I'll show you as well if you haven't seen video number 2. Purchase history, eBay, and I'll show you which ones I bought. Okay, we've got it. Now let's switch to the, okay, you've got it. So you see I bought those ones here. Metallized polyester film capacitors with plus 10 tolerance, yes, plus 10%, plus minus 10% tolerance, and I bought pack of 10 400 volts and capacitance 1.1 microfarads. 0.1 microfarads does mean 100 nanofarads. And on the schematics, yes, I'll show you on the schematics as well here. Okay, so we've got it, voltage feedback. The voltage feedback is here, yes, C11, okay, that's one of them, it's C11, voltage feedback, and then the output, so either IGBTs, where's IGBTs model, okay, here, and on the output you see it's still 100 nanofarads, C10 and C9, 100 nanofarads, you see everywhere it's 100 nanofarads, so that's the behind these MOSFETs here, guys. Here, I meant to say tuta in Polish. So those two. So those are the ones which I bought it for, but I've seen that I can use them elsewhere as well. That's 100 nanos as well. So 0.1 microfarad is 100 nanofarads, for those who don't know. And the last one where I've used it is I've used it as a C6 here. Okay, so you see, you buy one capacitor, and if it's up to the voltage, you know, it can work with a DC up to the voltage, the proper tolerance, capacitance, then you're fine. So let me pause and look at that for that CT, and I'll tell you where it is. Okay, got it. So this is actually here in the IGBT bridge. C6 is here, 100 nanofarads, 275 volt AC. Yes, so it has to work with the AC. So yeah, you need to know which capacitor you can use, because some of them needing the DC, some of them needing AC, and that's only what the last one I need to check. I do believe it's a right one, so I bought all of them for this purpose. I'll be checking still, but I assume it will be fine, and this way I could use 4 capacitors rather than 3 types of the capacitors. Yes, so that's me, that's my way at looking at it. If I'm wrong, please correct me, because you know, like, it's knowledge worth sharing, and I should make more videos about it. But for now I will stop. I want to make those tests. I want to add the heatsink element to it and the fan, make enclosure for it, so the circulation of the air will be proper, and then test it. I want to use my computer here. This in theory should get up to 500 watts. So, you know, like, I'm in a doubt that if you want, my application is to work something for 24 hours per day. So I don't like to use devices up to their limits, because I know they might struggle sooner or later. So I assume this 500 watts might be too much. We've got a transformer which 400 watts, it's not a problem for it. It's 24 to 12 volts. Yes, this one made for me, custom made for me, and that will be one of the next projects as well. DC to DC back converter, 400 watts. Yes, but constant 400 watts, and that's on 20 kilohertz. If I'll use 100 kilohertz, that will be even more. Yes, because I can go up to 100 kilohertz with this core and with this wire here and the design. Guys, 18 minutes, 19 minutes, let's call it a day. You've got a proof that Electronoobs pure sine inverter is working. Only you know what to do, the changes you need to apply if you want to build it yourself. Now I've got a good news as well. We will once we will build our inverters, we will decide which one will be to sell ready-made, as well as the DIY kits. if you know what you're doing and you're capable of doing it, of course, with a warning of it's a high voltage, you can get killed, so don't do it. Yes, but we will be doing it. It will be few, up to no more than probably about 10 models of low frequency and high frequency as well, and this will go from few hundred watts up to a few kilowatts in total. So we'll be up to 10 models, and we will create a CE mark for it, so we will do everything, the proper drop tests, you know, proper sticking stick inside and whatever those EN directives are asking us to do. Yes, so we will go through those processes and we will do them. So you will be able to buy either ready products from us, handmade in the UK, including transformers made in the UK, and fully fixable, complying with the right to repair, and you will be able to get each and every component to them later if anything goes faulty. But that's it, guys. Thank you for watching. See you in the next videos, probably now not about this inverter, and thank you for watching. Take care. Bye bye.